So we want to sketch the curve using the first and second derivative test of the function f of x equals 1/3 x cubed minus 1/2 x squared minus 2x plus 1. Okay, so the first thing that I'm going to do, in order for me to graph this, I'm going to do my first derivative. Okay, so the first thing I'm going to do is take the first derivative. Okay, I misspelled derivative. Derivative. Okay, so let me take f and let's take f prime. So let's just using the power rule, let's bring the 3 over. I'm gonna have 1/3 times 3, which is gonna give me 1. So I'm just gonna have x squared. The 2's are gonna cancel out in the second one in this part, so I'm gonna just have minus x, and I'm gonna have a minus 2 plus 0. Okay, so then I'm gonna have x squared minus x minus 2. Okay, so now what I'm going to do is I'm going to set this equal to 0, because once I set it equal to 0, I'm going to find all of my critical points. So I'm going to try to factor this. Okay, so I'm going to have an x here and an x here. Factor that, I'm going to have a 2 here and I'm going to have a 1 here. In order for me to get a -1, I have to get this to be a negative and this to be a positive. So my critical points are going to be x equals 2 and x equals -1. So these are my critical numbers, or my critical points. Oops, what happened? My critical, okay, points or critical numbers. Okay, so this is where I'm actually going to achieve a maximum or a minimum. Okay, so what I'm going to have now, I'm going to draw a number line to do the first derivative test. So here's going to be -1 and here is going to be 2. And what I'm going to do, I'm going to plug in numbers into the first derivative to see what whether I'm going to have an increasing or decreasing. So remember that if my f prime is greater than 0, this is going to be increasing. If I have f prime being less than 0, I'm going to be decreasing. So that just tells me what the slope of the line, of this curve. Okay, so I know that here my f prime is just going to be equal to 0. So this means that it's not doing anything. It's just constant. Okay, it's just going like this. Okay, slope is 0. Okay, so now let's plug in a point that is less than -1. So if I plug in a point less than -1, like -2, for example, all right, so when I plug in the -2 in here, I'm going to get a negative. And I plug in a -2 here, I'm going to get another negative. So a negative and a negative give me a positive. So over here, I'm going to have something that's positive. So I'm going to be increasing here. So f prime here is positive, so I'm going to be increasing. Okay, then let me choose something in between -1 and 2. So let me just plug in 0. When I plug in 0, I'm going to get 0 minus 2, which gives me a negative. 0 plus 1 is going to give me a positive. A negative times a positive is going to give me a negative. So right here is going to be decreasing. So you can kind of see that the graph is increasing, 0, and then decreasing. Okay, I know what happens at 2. Let's plug in a value greater than 2. So let's plug in 3. And when I plug in 3, I'm going to have 3 minus 2, which gives me a positive. 3 plus 1 is also going to give me a positive, so this is going to be upward. So here was negative, here is going to be positive. Okay, so we kind of already see what it's kind of doing. It's going upward, then downward, and then going back up. Okay, so that's really useful to have the first derivative test. Now, you can see that when it changes concavity, so when it goes from concave up to concave, concave down to concave up, something is going on. And what we really want to figure out is what are these inflection points. So let's figure this out. Now let's give a little bit more info on these points. So now that I know that now this is increasing and then decreasing here, and then here is decreasing and then increasing here, at x equals -1, I actually have a maximum, okay, a relative max. At x equals 2, I actually have a relative a relative minimum, okay? If I wanted to figure out what those values are, I would just plug them into the value of f. So now let's go ahead and do the second derivative test. Okay, so this is going to be the second derivative. And this will help me out identify my inflection points. Okay, so now I'm going to take the second derivative, f double prime of x. So I'm going to use this function now. This is going to give me just 2x minus 1, because 2 minus 2 is going to go away. Set this equal to 0. Okay, so when I add 1 to both sides and then divide by this 2, I'm going to get 1/2. So at x equals 1/2, this is going to be a possible inflection point. So sometimes we might have things that are not inflection points. So if it's not changing sign, it might not be an inflection point. Here, since it's 1/2, we can probably guarantee that it's probably going to be an inflection point. But let's go ahead and test it out. So here is x equals 1/2. So let's test it out. So remember that if f double prime is greater than 0, you have concave up. If f double prime is less than 0, you have concave down. Okay, all right, so now let's plug in a number. So let me plug in something that's less than 1/2, so let me plug in 0. When I plug in 0 into the second derivative, I'm just going to get a negative number. So we know that here it's negative. When it's negative, it's going to be concave down. Okay, here when it's greater than 1/2, so let's say 1, plug in the 1 in here. 2 times 1 gives me 1. 2 times 1 gives me 2. Minus 1 is going to give me a positive number. So here it's going to be concave up. Okay, so here's where the second derivative was less than 0. Here, second derivative was greater than 0. Okay, so this gave me a lot of really good valuable information. So because it alternates, this tells me that this is actually an inflection point. So it is an inflection point. Okay, now let's go ahead and graph it. So let me write down everything that I know from my first derivative. So for my first derivative, I know that here I have -1 and 2. These are my critical points. Here I have increasing 0, then it's decreasing 0, and then increasing. Okay, that's for the first derivative. So this is what f prime tells me. F double prime, okay, I know that I have x equals 1/2, which is around here. So x equals 1/2. I know from over here it's going to be concave down. Okay, so it's going to be concave down. And over here it's going to be concave up. Okay, and you can kind of see that, the concavity is actually going downward and then it's going upward. Okay, so you can kind of see all those points. Something that you can also do to make this graph a little more precise, you can try to plug in the values of x equals -1 and 2 to figure out how high does this go and also how low does this go. So let me plug in that into the original. So I'm going to plug in f of -1 to see how high this is going to go. So 1/3 -1 cubed minus 1/2 -1 squared minus 2 times -1 plus 1. Okay, so let's see what that answer is. So I'm going to use my calculator. I'm going to put 1/3 minus 1 to the 3rd power minus 1/2 times -1 to the square minus 2 times -1 and then plus 1. Okay, and what I ended up getting was about 13/6 or 2.17 around there. Okay, so 2.17. Okay, so that's how high that's going to go. And then this one is going to be, I'm going to plug in the value of 2. So this equals me plugging in the 2 here. So 2 cubed minus 1/2, 2 squared minus 2 times 2 plus 1. Okay, and when I put this into the calculator, I'm going to get -7/3. Okay, so, or -2.33. Okay, so that's how low that's going to be. This is 7. Okay, all right, so now we're kind of ready to graph it. So this gives us a lot of information. So -1, then this goes as high as 2.17. So let's say this is 2.17. So this is where that's going to be. Then 2, here is 2, and then at 2 is going to be minus 2.33. Something else that you can do is also you can plug it with 1/2 and you can see what point it actually changes concavity. So we know that less than -1, so everything less than -1 is going to be concave down, but it's also going to be increasing, then decreasing at -1 and going. So it's going to be increasing, right, concave down. So increasing concave down. Okay, then it's going to be 0, then everything after that is going to be going downward. It's going to be downward concave down. Then right when it gets to 1/2, it's going to start going the opposite way. So now it's no longer going to be concave down. Now it's going to be concave up. But it's still decreasing until it gets to this 2. So it's still decreasing until it gets to this 2. Okay, and then after the 2, it's going to be increasing back up. Okay, so this is kind of how the graph looks like. I'm a terrible drawer, so this is just a really good visual of what exactly this graph is. Okay.